Good morning and welcome back to this week's lectures. In the last week, we already started several types of annuities, and in particular, we focused on finding the present value and the accumulated value of those annuities. Before we learn anything new, I'd like to give you a quick and concise summary of the concepts and important things we have already started on annuities. The first thing I would like to review is actually a simple concept, time. So this is the first thing I would like to review with you. You may think this is rather simple, but from years or from my own experience, I often see that a common confusion part actually comes from the understanding of time. So in my examples, or in most of my examples, I tend to draw a timeline. Okay, and then I start to label it as 0, 1, 2, 3, etc. So here I need to be more specific about the meaning of those 0, 1, 2. Right? So here for each number I, it actually refers to the end of the ith year. Okay, so in my timeline, 1 means the end of the first year, 2 means the end of the second year. So when I say there is a payment, let's say here, that means I will receive a payment of $1 at the end of year 1 or at the end of the first year. So please make sure you understand the meaning of my timeline. And this is usually the standard way of putting it up. You can try your own preference, but I would not suggest that. Okay, so that is the first type of timelines I usually draw. That's most likely the case. Sometimes we will also have a little unusual case when I will specific the date of the payment. Let's say I will receive some payment on the first day of each year. Let's say January 1st. So let's just randomly draw a timeline again. Okay, let's hypothetically say we are at January 1st, 1990. Okay, that's where we are now. And I will receive first payment on January 1st, 1991. So here I will have one payment. In the next year, so it will be January 1st, 92. I will receive another payment. So let's assume it goes on and on until the first day of this year, 2020. Okay, I give you this example and I ask you what kind of annuities I have, right? Obviously, you need to count how many payments, right? And that's often the question. You may miss, you may count less or count more of one payment. So the way I usually do it is, well, you can always stretch out your fingers and start counting. That always works. And especially here, the number is not that huge, right? So you will be able to get it by counting your fingers in probably 30 seconds. But of course, I may start from 1880, right? Then if you try to count your fingers, it could take several minutes. So we need something more systemic to finish. Okay, there are many ways you can do it. The technique I often use is I don't look at it for the from this time to this time. Okay, what I do is I pick 2 or 3. Let's say I pick 2. How do I know I have 2 payments? Right, I just use the end year minus the current time. So if I'm at 90, 92, I know I will receive 2 payments because 92 minus 90 is 2. So now, if you want to know how many payments at the end, it will be 2020 minus 1990. So how many we have? So it's 30 payments, right? So here to here, I have 30. Okay. So that's my usual way of getting it correct is I try special value. By the way, that always works, in particular for SOA exams. If you want to calculate something that is generally true, it must be true for special numbers, right? So here I'm trying to figure out the number of payments from some starting number to some end number. Let's say here's I, here's J. I know it will be something related to j minus I. I just don't know whether I should use j minus I or j minus I plus 1, right? So here our our formula says it's j minus I plus 1 because there is a payment at I, okay? So that's what I usually do. So if you want to discount to this time, if you think this is time 0, so let me use a different color to denote. So if you label this as time 0, this will be 1, this will be 2, right, all the way to 30. So if you want to discount everything to this time, it is annuity immediate, right? So you can say this is an annuity immediate. So it's A stands for the present value at time 0. And since I have 30 payments, so here I have angle 30. A vertical line, and then I. This means the when I discount, I will need to use the interest rate of I. So, this I is not the same as this I. But sometimes I might want to discount to something down here, right? Further forward. So let's say, well, let's say 1987. Okay, then what can you do? Right. Of course, once you are at this point, you can go back. Then you just need to figure out how many years between 87 and 90. Right. That's very easy to do. Right. So you just use 90 minus 87. Then you have 3 years in between. So 3 years in between. Then if I want to know the present value on the first day of 87, I will need to times by a discount factor of 3 years. So I raise the power to the third times the present value at time 0 or on January 1st, 1990. So I use this example to show you when you have something more complicated, drawing a timeline definitely will help you. So please do not skip this step. Always draw a timeline, even when you are more advanced stage, okay? Now, with that in mind, somehow we are ready to actually review what we have studied. The first annuity we studied is Annuity Immediate. Okay, again, the timeline definitely helps. So now it's time 0, 1, 2, all the way to n. At the end of 1 year, I will receive $1. At the end of 2 years, I will receive another one, goes on until the end of n years. Oh, here's a typo, so it's 1. It's a unit payment, okay? Starting from the end of the first year goes on until the end of the nth year or year end, okay? I want to know the present value. Present value is always at time 0. It's always at time 0. So my A angle N. By the way, sometimes people don't write the interest rate I. That is because that is often fixed and it is the same for the same question. So there is no confusion if you drop this I. But our textbook always write I, so I follow the notations from the textbook. So I write A angle N, put a vertical line, and then I. So this means it's evaluated at interest rate I. Okay, so the present value, now let me stress, this is in fact at time time 0. So this is always at time 0. Okay. So in order to convert all the payments to the same point, I need to do a proper discounting. So for the first payment, I need to times by V, right? Because it's paid at the end of year 1. So I just need to discount by 1 year. For the second payment, it will be V square because I need to discount back by 2 years. Easily you can see the last one is V to the nth. It's obvious this is a geometric series. Geometric. By the way, if you really understand the concept of time and you know how to compute the summation of a geometric series, any annuity question you can handle. Okay. So let's review the formula for geometric. So it will be 1 minus the common ratio. Obviously, the common ratio here is V. On the numerator, it's A1, so it will be the first term of your series, which is V. 1 minus the common ratio. Here, common ratio is also V raised to the number of terms to be summed. So here, obviously, I have n terms, right? So I can stop here. This is the present value of annuity immediate. If you want to continue, so what is V? V is 1 divided by 1 plus I. Okay, so here if I want, I can either keep V or put it as 1 plus I to the negative n. So here if I want, I can times by 1 plus I for both numerator and denominator, then I will get the usual formula many of you have seen. Right. Remember that the textbook put a trick. If you are looking for the present value of annuity immediate, you divide by I. I is the first letter of immediate. Okay. If you want to know the future value always use S to denote. This is always at time n. Okay. Remember, I say time 0 or time n. That is with respect to this timeline. Okay, if you change the labels, the x labels or time labels, the corresponding time will change accordingly. So this will be the start. So this is at the starting time. Here is at the ending. Okay, at 0, that's because 0 is the beginning of the first year, and you start to receive your payment in the first year, although it is at the end of first year. Okay, and here n, I call it the end of the annuity because n is, well, you receive your last payment and everything finishes at time n. So when we talk about present value, it's always at the beginning of the of everything. And when we talk about accumulated value or when we talk about future value, it is always at the end of that annuity. That is extremely important for annuity due, which we will see. So for the future value, it's nothing but, from time 0 to, all I need to do is to convert from 0 to n, right? And the way I do it is by times the accumulated value factor. So you have this easy relation, so you can easily figure out the formula. But of course, we can write down what it is, right? My first payment, if I want to accumulate to, I went over, to n, how many do I need? I need to raise the power to n minus 1, because in total I have n years. I already used the 1 year, which means the remaining is n minus 1. For the same reason, the next one will goes to n minus 2, goes all the way until the last one. Last one, I don't need to times anything because it is paid at time n, and I want my future value to be at time n. So this is also geometric, right? You can either look at it backwards, or I can switch the position, right? I put it in this way. It's more friendly. Then I know this is another geometric. It is 1 minus the common ratio, which is u again. Okay, v, excuse me. The first term is 1. 1 minus the common ratio v raised to n. Okay, so this n here is the number of terms. How do I know I have n? So here 1 is v to 0. So 0, 1, all the way to n minus 1. Obviously, there are n terms. Okay, so if you want to plug in v is this, right? So eventually you will get 1 plus I times 1 plus I times the value of it. Oh, so here we are moving upwards. Excuse me, here we have a lot of issues. It's not v. That is my typo. So it's actually 1 plus I, because we are trying to do the accumulation. So, we accumulate, not discount. That's my huge mistake. So here we just need to replace. That's why, when I look at it, it does not look right. So here is 1 plus I. So we just need to change a little of things down here. So it's 1 minus the common ratio. Common ratio is actually 1 plus I. So the first term is 1. 1 minus the common ratio to the power of n. Okay. Here I can, of course, we actually have negative sign, but we can take out negative for both. Then I get 1 plus I to the nth minus 1, right? So if I want, I can factor out this 1 plus I to the nth. Then on top, I have 1 minus mu n divided by I. Exactly what I would expect, right? So it really, really helps when you write down the step. Usually, in pretty much all actuarial science textbooks, they really don't like to write down the mathematical summation down here. I feel that is really not good, right? They always come with formulas, right? They expect you to memorize formulas. Actually, there's only one formula if you ever need to memorize. That is the sum of a geometric series, right? Other than that, there's nothing you need to actually memorize. Even for geometric summation, it's easy to derive, right? So here, let me give you a little box to show you again how you can derive the geometric series. So here, let's use this V example, okay? So you are trying to, let's say I want to get this A, okay? And go N. So it's V plus V squared goes all the way to Vn. All I need to do is times it by the same V. So I get V squared, V cubic goes all the way to Vn minus 1. Okay, so then use this minus this. When I do minus, I use the cross 1. Okay, so then I get 1 minus V A angle N equals V minus Vn plus 1 equals, take out the first one. See, I already get the result, right? So this really not too much things you need to memorize. So everything should flow naturally. Okay. The next one I want to review is annuity due. Okay. This is so similar to annuity immediate. The only change is you somehow shift the timeline. So the first payment now is from 0. 1 goes all the way to here. So now we think the payment is made at the beginning of each year. So my first payment is received at time 0 because time 0 is the beginning of year 1. My last payment is received at n-1 because n-1 is the beginning of the nth year. Okay, so The new notation, you put double dots. So it's A double dot angle N at I. So again, it always helps to write down what you are trying to sum up. So we still want to know the present value at time 0, right? Still is at time 0. The first payment, there's no need to discount. It's just $1. The second payment has to be discounted by 1 year. So it's V goes all the way to the last payment is at N minus 1. So the proper discounting factor goes to N minus 1. Okay. So there are so many ways you can do. One possible way is, well, we can factor out something. I can take out 1 plus V, 1 plus I, excuse me. Then my first becomes V, the second becomes V squared, goes to Vn. So what's inside? Inside is exactly annuity immediate, right? So this is 1 plus I times annuity immediate, right? So that's not surprising because everything is shift backward by 1 period, right? So you receive the payment 1 year earlier or 1 period earlier. So all you need to do is to times the 1 period accumulation factor. That's all you need to do when you do things between annuity immediate and annuity due, right? So of course I can directly do the summation from here. It's again a geometric. So 1 minus the common factor or common ratio, which is V. My first item is 1. 1 minus V to the nth, right? So if you recall the definition of V, this becomes, right? So it's indeed 1 plus I times 1 minus V to the nth divided by I. This is exactly the present value of annuity immediate, right? So it really doesn't matter how you want to see it. So now, what is my future value? So this time, the future value is at time n, okay? Again, when we talk about present value, it will be the beginning of your annuity. When we talk about the future value or the accumulated value, it will be deferred to the end of your annuity. Although your last payment is made at n minus 1, but that is the beginning of the nth year. And when we talk about the future value, we want to go back to the very end, right? So the very end will be the end of the nth year, not the beginning of the nth year. Okay, so with that in mind, so this goes to, so the first one, if I want to convert to the, if I want to convert this to the last one, how many years? They are actually n years, right? Going from the beginning to the end, they are n years. So this is not new, you see, I tend to make the same mistake. So it's actually 1 plus I to the n. The second one, I will have 1 plus I n minus 1. I keep writing wrong things. Finally goes the last payment is here, right? So obviously you have 1 year to accumulate. Okay, so if you want, you can write it from the smallest to the biggest, so that things look more familiar. Again, this is a geometric, so it's 1 minus the common ratio. On top is the first term, 1 minus the common ratio raised to the number of payments. Here goes from 1 to n, so I have n payments. Okay, obviously this is, when you do it, is negative I, so I need to switch the order of this. I get 1 plus I times, here it be 1 plus I to the nth minus 1 divided by I. Okay, so of course it is very easy to see. I can factor this out, right? And then I will have exactly the present value of my annuity due, right? Again, that is expected because this is at time 0. And if I want the accumulated value at time n, I need to times by the AVL to the n year. Okay, so that's annuity due. Finally, let's review deferred annuity. Okay, so here I even don't want to call whether it's a deferred annuity immediate or deferred annuity due, because everything depends on how you see the timeline, right? So what I mean is here I can what I can do is I can move all the timeline forward, right? So uh, let me use the later on example to demonstrate. I don't want to erase everything. So let's say we have a deferred period of m years. So obviously here we have m years, or you can call it m periods, right? Because the unit does not need to be a year. So I start to receive my payment here, goes on. Let's say I have n payments, so it should be m plus n. So here I have n payments. So again, if you don't know how many you have, just put a number for n. Let's say n is 1. How many payments, right? Obviously, you have one payment, right? So the number of payments equals 1 or equals n. If it is n equals 2, I have one payment at n plus 1. I have a second payment at n plus 2. How many do I have? I have 2. Again, it's this guy, right? So that's why I know I have n payments, right? So put n to be a number, and then you will see how many payments you have. Okay. So this looks a little complicated, right? So again, let's say I want to know the present value. So present value, it will be at time 0. So I want to know how much the entire cash flow is worth at time 0. There are so many ways I can do it. Let's just call it a PV, okay, without putting any notation yet, because of course we know the notation. This is okay. This means it's deferred by m years, and starting from this m, okay, we have an annuity immediate for m payments, right? So this is the notation for this is a deferred annuity immediate, and it is deferred for m years. Okay, but that's not the point I'm trying to make. Okay, in my suggestion, always write down what you are trying to calculate, not formula. Formula is not important, right? So here I have n payments. I need to discount all of them to the same time point 0. So for the first one, I need to discount all the way to 0. How many years? Right? This is rather easy to see, right? From 0 to n plus 1. So obviously I have n plus 1 years to discount. Okay. So uh, obviously you should know how to continue, right? The next year I need to add up by 1, goes all the way to n plus n. Okay, that's because if I want to discount this all the way back, I need to go back n plus n years. Okay, so this is really, really crucial. Many of you probably don't like to write down, but from now on, I really, really want you to write down this as the first step. It will definitely help you to understand the true mathematics behind it. And once you understand the mathematics behind everything, you should be able to figure out everything about annuity, even say 5-10 years from now. Okay. So this is a geometric series. Right. So let's do it in a mathematical way. We can directly calculate what is the common ratio. Common ratio is the next one. Let's say this divided by this. You get v, right? So my first term is v to the m plus 1 times 1 minus the common ratio, which is v. I need to count how many terms, right? So it starts with 1, it ends with n, so I know I have n terms. So period, it's finished, right? You can leave this as the formula for the deferred annuity immediate, but we can do so many things from here, even just mathematically, okay? So what I can do is when I write down this, let me erase this. This is not, so when I write this down, when you look at this, we can factor out this guy, right? Because all of them have this. If I factor out this common factor, what I have inside is v. The second one becomes v squared. The last one becomes v to the nth. Now, what's this? If you forgot, go up here, right? It is nothing but the present value of an annuity immediate, right? So this is Vm times annuity immediate. Okay, this is because if you look at this, if you think, I need to introduce a new set of timeline. Let me draw it here. Okay, to help you understand why this is the correct formula. Remember, we used to have this. Okay, let me now use the original color because time is all that matters down here. So here is M, here is 0, here is M. Okay, I have the first payment goes all the way to M plus 1. So I know here I have M payments. Now let's do a magic change of timeline. So now I don't see this as M. I treat this as 0. So put something different. Let's put tilde. Okay. And then this becomes 1 tilde. Okay, goes all the way to N tilde. Right? So if I do this new timeline, so M in the original timeline becomes 0 in my new timeline, and M plus 1 obviously becomes 1. So finally, here is M plus N becomes N tilde, right, in my new timeline. So with that in mind, in this new timeline, this is nothing but a standard annuity, right? And when we calculate the present value, it is always at time 0. So my new time 0 is here. So I know this is an annuity immediate, right? Okay, but this is at my new 0 tilde. Okay, the changed timeline. This is not exactly what I want. I want to be at the original 0. How do I go from this new 0 to the original 0? Right? Just need to discount by m years. This is exactly the meaning of this formula, right? We calculate the present value of annuity immediate, but the value is at time m. If I want the present value at time 0, I need to discount back by m years. That is reflected by this discounting factor v to the nth. Okay, that's not the end. There are so many things I can do. So what if I factor out the entire n plus 1? Then inside will be 1 plus v goes all the way to v to the n minus 1. So this is v to the n plus 1. This is the present value of annuity due. Again, everything makes sense if you draw a timeline. So I want my present value to be evaluated at this original 0. So let's say this is the last payment. So now let's do time change. Okay, so I know my first payment is here, last payment is here. So right now, I want this. Let's try different notation. Let's call this hat 0. Okay, then this will be hat n minus 1. Right? Because I want it to be an annuity immediate. The first payment of an annuity, an annuity due is paid at time 0. It's paid at time 0. So I need to convert this to my new 0. Okay, the last payment is paid at n minus 1. So at this point, what I have is an annuity due, right? Again, present value is at time 0. This is the present value at my new 0 hat. It's not what I want. I want it to go back to this 0. So I need to discount how many years between the original 0 and my new 0. N plus 1 years. That is why I need to discount back by n plus 1. So that's why, there are so many understandings. There are actually even more from here. So again, let's draw timeline. So here is n, here is n plus 1, here is n plus 2, goes all the way to n plus n, $1. Okay, so I want to know the present value at time 0, but this is not a standard annuity, right? So let's do more magic. So I put dot, this is a dotted line. So imagine I have this new payment. So what I do is I add those payments in blue. Then what I have. So if I consider everything, what I have is an annuity immediate, right? Because the first payment is at time one, right? So how many do I have? Again, here's n plus n. How many do I have? Right, 1, 2, 3, all the way to n plus n. So I have n plus n payments. So this is a standard annuity immediate, starting at 1, ending at n plus n. And in total, I have n plus n payments. But obviously, the blue ones are imaginary, right? Those do not really exist. What really exists are the pink ones. So if I add those, I need to subtract them back. So I need to subtract them back. How many blue payments? N, right? So this is originally what I'm trying to calculate. It is a deferred annuity immediate, right, with n payments. So I have this, right? What if I want to do one more step? That is, if I want to use annuity immediate, what would be the case? So again, draw a new timeline. So let me label everything to n plus 1. I have one payment, goes all the way to n plus n. I have the last payment here. Again, this is the original setup, right? I have $1 to be paid from n plus 1 to n plus n. I don't even need to specify whether this is annuity due or annuity immediate. It doesn't matter, right? It only depends on how you look at the timeline. So now I want annuity due. So let's try this color. Annuity due, the first payment must be made at time 0. So I add these brown payments. Okay, so still I'm looking for the deferred annuity immediate. So now if I add both brown and pink, what do I have? I have annuity due. Okay, put double dots, is a due. How many payments? The first one is made at 0, second one is 1, third one is 2, all the way to n plus n. How many? N plus 1, right? Again, if you're not sure, look at 0. At 0, you have one payment, right? So the number of payments is the timeline plus 1. At time 1, I have 2 payments, right? 2 is 1 plus 1. At time 2, I have 3 payments. That's 2 plus 1. So it will be the number at the end of the year plus 1, right? Okay, again, of course, I added something, right? So those brown payments are imaginary. They don't exist. So I need to subtract them. How many? 0 to n, I have n plus 1. Again, it's easy to figure out because the number of actual payments in pink is n. So if I have n plus n plus 1, I need to subtract n plus 1 in order to leave me with the original n payments, right? So how many equivalent formulas I have? Here is 1, here is 2, 3, 4, at least 4, right? If you count the original one, the 5 or 6, there are different ways of expressing deferred annuities, okay? That's everything I want to review.